every rock we turn over looking for something, it turns out to show that the low carb diet is better. So
I'm here at Low Carb USA in San Diego, and a friend and huge supporter of mine over the last couple of years, I must say, Dr. Michael Eads. Delighted to meet you here.
Oh, my pleasure.
Again. And we've met in South Africa and Vail as well, and this conference is looking pretty good. It's been a great experience.
Been a terrific experience.
Yeah. So you are, I won't say grandfather, that sounds ageist, but such a huge force in low carb from the 80s, from Protein Power, and yourself and Mary so far back. And your talk that you gave, I mean, it's great because it culminates in a series of points of evidence from many different spheres for low carb being an optimum human diet. So maybe it'd be good for you, in your own words, just to give that kind of evidence base at a high level.
Well, there's a lot of evidence out there that I think shows low carb to be the optimal diet for the vast majority of people. And if you look at the anthropological evidence, that's one point, because obviously in our Paleolithic ancestry, people ate what they had that was available, and they didn't have high carb foods available. I mean, they had some roots and shoots and tubers from time to time, but they didn't really have a lot of high carb foods. And people that were Paleolithic people in Northern Europe, for example, didn't have any high carb foods during the winter. I mean, all they had was game, basically. And so and that was where our genome was laid down, especially if we're European. That's where our genome was laid down over the millennia that people ate like that. And so that's one point of evidence. Another point of evidence is just the multitude of randomized control trials that we have now. I mean, we have, that I can think of off the top of my head, 30 or 40 that where low carb and low fat diets were compared head on, and the vast majority of those low carb was basically triumphant. People lost more weight, got better lipids, reduced their blood pressure, stabilized their blood sugar, and so the vast majority of those studies showed that low carb was vastly superior to a low fat, higher carb diet, and the ones that it didn't show that, it was basically a tie.
Right.
So when you you look at it from an overall perspective, the low carb diet was really triumphant. So you've got the anthropological data, you've got the randomized controlled data. If you look at this huge database that's out there of ancient Egyptian mummies, which have been studied extensively, what you find is that these mummies, the people who became mummies, the ancient Egyptians ate a diet that was low carb, low fat, high carb, primarily wheat based. This was 1,000 years before sugar even came on the scene, so they didn't have sugar. They had a diet that almost any nutritionist would recommend now to prevent heart disease, to prevent diabetes, to prevent weight gain, and yet the Egyptians were obese. They had signs of diabetes. They had signs of high blood pressure, which can all be seen from the mummified tissue. And they had heart disease, surprisingly enough. So when you look at this ancient Egyptian data, which is really a lot larger than most people would think it is, in terms of amount of evidence available, that shows that the low-fat diet, high-carb diet was a failure, at least as it applied to them. So that's another piece of the puzzle that you can add in. And then you can add in what are called the metabolic constraints, which is an interesting concept that's kind of technical, but basically it also shows that people basically evolved because they ate meat. Because if you look at primates, they've got small brains and large bellies because for the most part primates eat plant-based food. Gorillas, chimpanzees, chimpanzees eat a little meat, they hunt a little bit, but primarily they eat a plant-based food, and almost all primates do. And as we evolved from that, we had to grow our brains, but because of these metabolic constraints, which is a theory that was developed by a guy named Max Kleiber at University of California, Davis many years ago, metabolic rate is a function of size. So if you're a given size and you increase your brain, which is hugely metabolically hungry, something else has got to give. Your heart can't give, your kidneys can't give, your liver can't give, but what can give is your GI tract. If you're eating a much more nutrient-dense diet, which is what meat is. And so that's what happened when we began hunting and quit eating vegetable foods, as our guts shrank and our brains expanded. So that's just another piece of the puzzle. And when you put all those together, the randomized control trial, the Egyptian studies, the anthropological data, the metabolic constraints, it all points to the fact that the low-carb diet is really the best thing going. And then when you look at the evidence that they're doing now on athletic performance, and you get superior athletic performance on low-carb ketogenic diets in particular, that's just another piece of the puzzle. And everything, every rock we turn over looking for something, it turns out to show that the low-carb diet is better. So
that's a great summary, Mike. And even all of those trials, randomized control trials, a lot of the time you had a kind of an ad libitum low-carb diet against a calorie-controlled carb one.
Yep.
So they almost disadvantaged low-carb.
Exactly. They put it in a bad light. And then the other thing about all of those trials is that they used a method of analysis that kind of makes low-carb look not as good as it really is. And so, I mean, it's really a complex thing, but so essentially the deck was stacked against the low-carb diet, and it still won.
Yeah,
and what's interesting is we all started on this low-fat journey, where everybody was recommended to go on a low-fat diet, a low-fat, high-carb diet. We started that out with really no evidence at all. I mean, it was speculation, it was a guess. I mean, some people just decided that was going to be written into the nutritional guidelines, and so the whole country went on this low-fat, high-carb diet. And it was basically an experiment. I mean, it was based on no hard data, as you well know. And the results of this experiment now, obesity is at an all-time high, type 2 diabetes is at epidemic levels, so it's clearly failed.
Absolutely.
And so now low carb is kind of growing as a movement, and people are reversing diabetes, completely reversing diabetes, type 2 diabetes. They're having a much better time, easier time losing weight and maintaining weight loss. So I think we're going to see a movement in the other direction. At least I hope we do.
Yeah, certainly. And I know myself, I mean, for a few years ago, I made a directory and where I had all my papers piling up called Fat is Bad. And I purposefully said, okay, any evidence against this, I'll put it there, and I'll try not to be biased, but it never really filled up. So as you say, the vast preponderance of evidence is behind low carb, but the whole world is wedded to high carb and are going to find it very hard to give it up. So as you say, there's green shoots now, there's conferences like this. But how do you view the next, say, 5 or 10 years? How quickly will this obvious truth begin to really get out there in mainstream?
Well, I mean, I think the key to the whole thing is the United States nutritional guidelines, which come out every 5 years. And the nutritional guidelines are basically put together by a group of scientists who are selected to do that. And it seems like that every 5 years, the group of scientists that they put together are old school, who have their careers are invested in the whole low-fat, high-carb paradigm. And it's difficult for anybody to say, hey, the last 40 years of work I did is worthless. I was working on the wrong thing. So you're really not going to be able to get them to do that. And like Max Planck said, science essentially advances one funeral at a time. And so when the old guard dies out and all these new guys that are coming in are the ones that are selected to be on the board to put together the nutritional guidelines, I think the nutritional guidelines will change. And when those change, I think things are going to change, because the law requires, as it's now written, requires that the government feed anybody the government feeds in accordance with the nutritional guidelines, and the government feeds about 57 million people a day. So they're all getting the low-fat, high-carb. And then food manufacturers, they jump on the bandwagon. I mean, they really wait to see what these guidelines are going to be, and then they make foods that conform to them so that it looks good on the label because they're within all the right ranges.
Yeah.
And I think that it's going to be a key to change the nutritional guidelines, because when this obesity epidemic and diabetes epidemic that we're in right now started, it was when the first nutritional guidelines came out.
Yeah, almost.
And the manufacturers, the food manufacturers, everybody jumped on the bandwagon and started making everything low fat, high carb. And there is a lot of evidence, at least strong evidence to me, for example, that saturated fats, which have plummeted because they've been vilified, they've plummeted in the food supply, and everybody's avoiding saturated fats. The saturated fats are not only not harmful, I think they're actually helpful, and by getting rid of them, we've done ourselves a disservice. But I used to think that saturated fats were kind of just neutral fats, and I couldn't see why they were vilified, but now I've come around to a way of thinking that they're actually helpful versus neutral. And when you get rid of something that's helpful and you replace it with something that's harmful, and I think vegetable oils really are harmful, then you really take a turn for the worse. And for example, not going to mention any names, but a large producer of French fries used to cook their French fries in beef tallow, which is primarily stearic acid, which is a long chain saturated fat.
Stable.
That when you actually look at stearic acid, you find out that it does a lot of things good. I mean, it reduces cholesterol levels. Stearic acid does. I mean, it's a really interesting saturated fat, and that's I think the primary saturated fat in beef tallow and beef fat. And so there was this outcry because this company made their French fries in saturated fat. So they started experimenting around until they figured out a way to cook them in vegetable oils, and then food technologists figured out how to add the flavor of the beef fat in. So these French fries went from saturated fat French fries to vegetable oil French fries, which was a huge turn for the worse, because the vegetable oils kind of magnify the effects of the carbohydrate, whereas the saturated fats kind of protect against the effects of the carbohydrate.
Somewhat, yeah.
And so it took a product that tastes the same now as it did then and made it vastly less healthy, while at the same time convincing people that it was more healthy. So, it's a strange deal. And so I think one of the big problems is the avoidance of saturated fat and this switch over to vegetable fat, because vegetable fats are not anything we've encountered in our millennia of evolution in any quantities until the last 50, 60 years, when they were supposedly heart healthy.
Yeah, they're, I believe, malign influence. And they're still supported. So although people are backing off, I think the American Heart Association last year acknowledged from all the big studies, epidemiological and trials, that saturated fat, there's no evidence. In fact, if you replace 5% of sat fat with carbohydrate, there's 7% more cardiac disease. Now, that's in the report, but they're not very loud about it. But these vegetable oils, all the associational data is now suggesting that the polyunsaturated oils are really beneficial. But that's mainly associational data, right?
Right. And I mean, if you just look around, people are eating more vegetable oils, and obesity is everywhere, and type 2 diabetes is skyrocketing. There's really been no major reduction in heart disease or cancer. So how can they be helpful when we've all gotten worse, or at best stayed the same in certain disease processes? So I mean, I think vegetable oils are kind of disastrous. And when that really clicked with me is when I was looking at non-alcoholic fatty liver disease. And non-alcoholic fatty liver disease is now present in between 30 and 40% of adults in the United States. And that's just a fat accumulation in the liver. And it accumulates the same way in people that drink too much alcohol. And if a pathologist takes a liver biopsy and looks at it, he can't tell the difference in liver disease caused by alcoholism and liver disease caused by sort of increased carb consumption. And if you look at both of those, you can't tell in a microscope. And the only way you can tell is whether there's a history of excessive alcohol consumption.
Right.
So that's how you differentiate.
So by
It's exactly the same disease process. And if you take animals, and this is written up in many, many papers, if you take animals, laboratory animals, because you can't do this to humans for ethical reasons, you'd never get it through an IRB, but if you take laboratory animals and you make them get fatty liver disease, and you do that by giving them alcohol, or you can do it by giving them large loads of fructose. But if you do it by giving them alcohol, which is the quickest way to do it, if you give them alcohol and feed them saturated fat, you almost can't give them a fatty liver.
Right.
But if you give them alcohol and you give them vegetable oils, it accelerates the process.
Explodes.
So that when I started reading those papers, I thought, wow, those vegetable oils are more than just what I thought they were. And so then I really started thinking about it, and I think vegetable oils are really awful.
Yeah.
I mean, I think if you're going to eat oils from plants, you ought to get oils from plants that you can squeeze it out of. I mean, you can squeeze corn till the cows come home, and you're never going to get oil out of it. You're going to get corn juice. So it's got to be chemically extracted, and it's not an oil that we're used to eating in large quantities without all the other stuff that's in the vegetable it comes from, and corn in particular. And so, and that's the major oil that people get, is corn oil.
And actually, I know there aren't many RCTs on vegetable oil, but the few from 30, 40 years ago, I think Sydney Heart Trial, the Helsinki Businessmen's, there's a Minnesota Heart Trial, and there's one more. And all of them bombed.
Yeah.
Where the higher omega-6 vegetable oils had much higher death rates, but they were essentially suppressed. I mean, not a conspiracy, but it kind of is, because they were buried.
Yeah. Well, I mean,
shocking.
that in my view is a big problem with science today, because I mean, the way scientists communicate with one another, other than in conferences like this, is via the scientific literature. And there's so much stuff in the scientific literature that doesn't really get suppressed, but it doesn't get magnified either. I mean, the press doesn't jump on it. It's it's a matter of reporting, I guess. But there are a lot of studies that are, they're not suppressed. They're just they never see the light of day.
Yeah.
So a drug company, for example, could sponsor 5 studies on a specific drug, and 4 of them bombs, and 1 of them shows the drug has advantages. That's the one that gets published. The 4 that bomb stay in the desk drawer.
Yeah, and the citations, I think someone did a study once and found essentially that, but the citations are enormous for positive results.
Yes, exactly.
And then there's no citations for ones that prove null.
Right, exactly.
Yeah, so science published is inherently biased just through that mechanism.
Exactly.
Never mind all the other. Yeah.
And it's, and it's difficult to get nutritional studies done because they're hard to get funded, because there's no, you can get drug studies funded because if you get a drug out of it, that drug's going to make tons of money, so it's worth the investment. I mean, who's going to invest showing that corn oil is bad? Nobody. All the money's in the people that make corn oil, and they're certainly not going to invest in that study.
No, and then a risk of proving the current paradigm's incorrect. Generally, there'll be efforts made not to do that.
Exactly.
Because where's it going?
Exactly.
It's going nowhere good.
Exactly.
Oh yeah, bias.